Welcome to another webinar in the COVID-19 INSPIRE Hackathon webinar series. Today we are going to talk about how we can calculate agro-climatic factors, and you will learn what it is. My name is Bente Lilja. I'm going to be your host as usual, and we will start the event by going through some weather reports. And in this case, weather is actually also important further down in the webinar here. So we have a chat, and we want to ask you to ask questions and comment in the chat. And you can start by telling us where you are, what you're doing, and we want to know the weather where you are. We will start by showing you how to give a weather report here in this webinar, and you will learn more about the presenters shortly, but first you will learn where they are and what the weather is like. Mike, where are you and what's the weather like?
Hello, my name is Mike. I'm sitting in a small village near to Pilsen, Czech Republic. We have really rainy weather today, and about 11 degrees only. And it's really raining after a long time. So we are very happy with rain.
You needed rain. Good to hear that you're welcoming the rain then. Carol, how about you?
Hello, I just disappeared at this very specific moment when we went online, so sorry about that, but for now, hopefully you can hear me. I'm Karel Jedlička, and actually I'm not that far from Michal. It's also raining here, but that's the smallest issue I was having like in last 5 minutes. So yeah, but for now I'm up and running and ready to run the webinar.
It's fine with you if it's raining. It's fine with you if it's sunshine. It's all good. So, well, I'm in Norway, so I'm not in the Czech Republic. I'm in Norway, very close to Oslo, a little bit northwest of Oslo, in the countryside, and we have a beautiful autumn day, just clear skies and sunshine. So I'm really happy to see that, I have to say, because it tends to be quite dark and a lot of rain and grayness during the falls here in Norway. Anyways, we have beautiful weather, and we have people rainy. Pavel has a rainy weather and 10 degrees. Jörg is from Leipzig, and he has 9 degrees and raining. So I'm the lucky one so far. Okay, thank you for that. Remember to ask questions and comment in the chat. We have 2 presenters, as you can see today, and but we will like you to ask questions even if you come up with the questions during the talk, the presentations. Please ask it, and if you have comments as well, by all means, we want to hear from you. That's the message I want to convey. I think we will be about 45 minutes or so today in this webinar, depending a little bit, of course, on how active you are, how much you want to use this opportunity to ask Carol and Michael. We are going to cover both the concept of agro-climatic factors, so what is agro-climatic factors, and how to calculate them. That's the topics, and you will learn about this concept, so just be patient, and you will learn a lot today. Starting with an introduction to the challenge in the COVID-19 INSPIRE Hackathon, and by that I give you the floor, Carol. And introduce yourself before you turn on your screen share as well, so that we learn a little bit about you, and then when it's Mike's turn, you will learn about him. Okay, Carol.
Hello again. My name is Karel Jedlička. Thank you for the word, Bente, by the way, and the introduction for the whole webinar. But about my professional background, I work as a geomatics expert. I work with geographic information systems, and here we apply these skills towards agriculture, precise agriculture, smart farming, however you want to call it. But long story short, in one sentence, our aim is to allow or to interpret climate-related data into a form which could be of use for a farmer in the field or some farming expert. So this is actually our work, which is like maybe running for 3 years or so, and we are now in this specific challenge. In this hackathon, we are somewhere in the middle of a piece of work we would like to do in this particular hackathon. So just let you know that there is still a chance to join our team if you are interested. If you go to the Plan for EU to the specific challenge number 13, you can register for the team and cooperate with us. And I just hope that after we end this webinar, our work will be much more clear in technical details. So what we just want to do is actually turn data into information. It's a saying which is widely used, but in our case it means like to work with temperature, sunlight, evaporation, water cycle, etc., and to calculate some climatic factors which influence agronomy, farming. So this is why it's called agro-climatic factors actually. So here you can see the factors. And of course, we will discuss which data we will use for calculating those factors, going through pros and cons of these factors, etc. So this is just very brief introduction of the challenge. If there is any question related to the challenge now, I'm happy to answer it. If no, then I will just go to the presentation, which will go into detail. So I don't know if there is something in the chat. If I see it well, there is still the weather report only. So, but if
yes.
there is any questions.
Well, Carol, actually, I want to ask you a question before you go on, because you are talking about agro-climatic factors in and agriculture, but this is a COVID-19 INSPIRE hackathon, and if you could relate this to the pandemic situation. Why is this relevant for the pandemic situation?
Yeah, we discussed that actually for quite a long time before we entered this challenge. But the relation we see here is that relevant information can help in the food chain, in producing the plants in a way which is suitable for a particular place, etc. And we hope that using relevant and up-to-date information, maybe we can even with less contact among people, etc., to harvest similar amount, or at least not too decreased amount of the crops. We are not sure if that's the strongest connection, but at least it's a piece in the puzzle which maybe can help. So maybe we can, after the end of my presentation, or even after Michael's presentation, to come to this question again and see if what is the vision of other people, if they see some connection, or if they have more detailed questions related to the relation to COVID-19.
Yeah.
Want to mention, I'm receiving some private questions like I hope I'm muted, etc. So I just would like to ensure participants that they are by default muted, all of them, and this you are listening just to voice of presenters. So that's fine, don't worry.
And thank you for. I just want to swoop in some more housekeeping as well. I'm sorry I forgot to talk about that, but I see that Rodrigo, sorry, has asked for the floor, and in fact, you can raise your hand and ask for the floor. In order for us to be able to invite you inside the webinar room, you have to be inside the webinar room to be able to speak and be invited. And you have to be invited. I need to accept your request, Rodrigo. And the requirement, just an FYI here, the requirement for doing so to get into the room is that you have, in fact, a very good stable internet connection. You need to have a Chrome browser and a webcam and a microphone, of course. So if you have that, we will be able to invite you into the room, and we will do that. I believe we can do that after Mike has done his presentation as well, in order to make it not so. In case we enter some technical problems, it's easier to do that towards the end. But you can all the time ask questions in the chat. You can also comment in the chat, and we will read those questions in the breaks during the talks. Okay, I want to add one perspective. As you said, Carol, you asked if people have some other ideas on how we can link why calculation of agro-climatic factors is relevant for the pandemic. I know that in Norway we were discussing the access to food, taking that the transport of the importation of food from other places in the world, near or far, were limited due to the pandemic. So it's not only the protection, as you mentioned, to reduce the contact points, to reduce the spreading of the virus. That's one perspective. But another thing is, do people actually have the capacity to produce the necessary food? And what this is optimizing, as far as I understand, what you are doing is trying to optimize the productivity of the farms. So hopefully be able to produce more food, right? Is that correct, Carol and Mike?
At least the same amount of food. It's not always about the growing, etc. We should imagine also the negative connotation of, but it should help. Like if you compare the situation with the information and without, it should be better with the information related to climatic data. At least we hope for, because otherwise we wouldn't do that. Yeah.
Okay. If you have, I don't see any questions, Carol, so I think you can go ahead. Yeah.
Yeah. So hopefully you can see my screen now. You can see that our team consists like of 5 people right now, and we invite anyone else to join us for sure. And now, I need to move to the right screen. Yeah. So I would like actually to tell you some kind of a story, let's say, of a fictive farmer who looks for a particular place which would be suitable to grow some particular plant, to find some match in between plant and the place, and use relevant data and up-to-date technology to support his or her decisions here. Of course, sometimes the place is locked and you are searching for a plant. Sometimes the plant is locked. This is what you want, for example, to plant, and you're looking for a particular place. So it could be used. The data could be used both ways for sure. So again, now what's the agroclimatic factor? We can, from one aspect, we can see it also as some part of agro digital twin. So a twin of a farm, of an area of interest, which would get enough digital data to model and simulate what can happen in reality. So these are this popular what if analysis, etc. So from the perspective of climatic data, we have a data source, I will talk about it later, which has about 40 years of climatic data stored, and you can access them for free basically. And you can get from that source information about the solar radiation. You get access to water balance, which means like what was the rainfall, what was the runoff, what is evapotranspiration, etc. Next, we can work with factors which are calculated from temperature, like searching for days where there is no freezing in the area, so we can understand as days in which we can start planting, for example. Then we can discuss how many heat units we need and when we get them for grow the plant. Actually, here is some corn, for example. You will see the image later on again. And another type of agroclimatic factor is to calculate a time window in which it's suitable to after the season to apply nitrogen into the soil, so you ensure that the nitrogen will stay in the soil and doesn't disappear. So these are actually factors which differ place to place, and we can describe each particular place by these factors. And because each crop actually has a bit different needs from this perspective, you can then search which plant or group of plants is suitable for a place and which is not. So this is the decision which needs to be done afterwards by the farmer. Basically, it was a short description of what we want to achieve, and now I will go a bit more into detail. So when we start some research, we find some we feel interesting facts which are here on the screen. So first, usually these agroclimatic factors are calculated from local data, from local meteorological stations, for example. In this case, you get much better accuracy of the data, but usually you don't get that long time series, because you get time series like a year, 2 years, whatever, but not 30 years. So we still see some potential using the global data, even if they are not that granular. Here are some not that relevant findings, so I will skip them. Yeah, the next important thing is that usually you can find, okay, you get the GDU, growing degree units calculation, and it's like, let's say, 250 days in a year for that place, but you don't get the exact description of the algorithm. So one of our aim is to publish the algorithms, and that they are already published on GitHub. I will show the link later on. So you can follow our approach. You can use the same algorithms. They are for free. You can say, okay, your algorithms are not the best one, I know a better one. Then let's discuss and try the other algorithm, whatever. This is still open research. Yeah, and the last bullet here says usually you have already calculated data and the result, but we want to achieve a situation where you have a server which can calculate the agroclimatic factor for a particular place on demand. So it means that you can repeat the calculation, get it for different years, whatever, so you can play with the data, etc. Okay, so this is our starting point, and I already mentioned some ideas where we want to go. Here you can see on the slide, I divided the factors into 4 different groups, like related to temperature, to soil temperature, which is a bit different than air temperature for sure, to sunlight, and to water cycle. As I mentioned, you can find this this GitHub repository. Here is the shortcut, so you can use it, and I will also copy the link into the chat. So hopefully it's there. Yes. And just to let you know that there is some wiki page. There are algorithms described. There are these kind of schemes I will talk about later on, and you can see the description of each particle agroclimatic factor we developed here. For the presentation, I will go just for the first one, for the frost-free period, so you will understand how to actually read the GitHub to get the information. We understand that the farmer is not a typical user of GitHub, so we have in mind different user interface to communicate with farmers, but I will come to that later. Now I go to this one example, which is the frost-free period. We are basically searching for the last day of freezing and the first in spring, and the first day of freezing during the fall period. So this is about getting the temperatures for the whole year, and then to extract from the data set, we get hour by hour temperature. So it means 365 days multiplied 24 hours. So this is the set we have to search in. And we are looking for temperatures below zero there. We are searching the last frost day, which could be set up for sure for a particular year. But if you want to get some kind of prediction, you better go for searching like for last 5 years or 10 years, and search some probabilities of will there be some freezing after 5th of April, 6th of April, etc. And this is actually how the prediction can then be done. And I will show you the result in next slide, I think. So yeah, this is the probability as I mentioned. And usually you here search for pretty low probability of a freezing after a day, a particular date, because if you plant something, then freezing gets it's a problem, because in that case the plant can get several severe damage. I have a question from York. If our local, I will repeat the question. Do your local weather station sensors provide all the data used from the global data sets? I will come to that question maybe afterwards, because for what I present right now, it's the global data set called ERA5, climatic data provided by Copernicus Data Service. And this is somehow, they call it reanalysis, and they basically tell you this temperature, for example, it's on that particular day and hour, it's 5 degrees Celsius, with the probability, with let's say uncertainty of plus minus 1 or 2 Celsius. So this is not that ideal actually for frost-free. And we have to be very careful with that. But we also plan to work with some correlation to meteorological stations, and that's how you can calibrate the global data to local conditions.
Yeah, Carol, yeah. I suggest that you leave the chat box to after your presentation, okay. And then we take the questions in a break. So we collect the questions in one go. So yeah, so never mind what happened in the chat for you right now. we take that afterwards. Okay.
Okay. Yeah, but I wanted to actually because anyway.
It's a natural break here now.
It could be because I just explained the, let's say, the methodology behind, and now I would like to show a particular example. So maybe if there are some other questions to the methodology, otherwise we can.
Yeah, you can unshare your screen also, Cattle, so
Okay.
we can see you change the scenery a little bit.
Okay.
So here we are again, in case you were thinking you lost us. Yes, so you partly answered the question to Jörg. So Jörg, thank you so much, by the way. So do your local weather stations, and so sensors provide all the data you use from the global data sets? So I assume, my take on it as well, I assume that the weather stations are varying, they are not the same ones in all the places, right? That you have different, yes. So can you talk a little bit around that, the variety of the data collected on the ground? I mean, yeah.
Well, this is maybe a question more to Michael, because I know only that you mentioned that the weather station vary depending on the hardware you buy, but yeah, if you Michael want to put some detail there.
I'd say data we are using at this moment as validation data set for this comparative task. That are data collected from 5 to 3 years ago. So it's from 2 different projects, and it was measured by 2 types of metal stations. Evapotranspiration, as Jörg is asking, it's not measured or not produced by the metal station. So we limited the number of phenomena we are taking into account to the common data set. So from both metal stations, we are using air temperature, air humidity, air pressure, and if it is possible to take precipitation as well. So these 5 phenomena we have in common, and we are calculating with them.
Okay, so this means that you are testing out with a few factors. As you said, you're limiting the factors, but if you have, in principle, you could also in the future then include other factors if you got the information. Yeah.
If you get information.
Yeah. So this is maybe, I don't know what you can do during this challenge, but this is definitely, I guess, something that you can discuss in the challenge as well, what is possible. And maybe, I mean, I think you are using this on fields in the Czech Republic, or are you using in other areas? No, it's the Czech Republic, right?
It's in the Czech Republic.
Yeah. So I mean, the satellite images, of course, they are global, so they will cover any place. And what would be interesting, if there's somebody here that wants to engage in this hackathon, maybe they have access to some data from ground instruments on other fields that could be, validating and expanding your project here, right?
That would be perfect, exactly.
Yeah. Okay. Yeah. Thank you, Jörg, for an interesting question. I don't see any more right now, but please go ahead and ask. You see, we can have very interesting discussions based on that. So with that, Carol, I think you can continue your storytelling.
Okay, I will continue now then. So see my screen again?
Yes.
And let's say I will now show what you can achieve with using the data. We picked just a place with particle coordinates here. It's a place in the Western Bohemia, but our algorithms are actually programmed in the way that they can handle data from both like southern and northern hemispheres. So we are not limited to any particular place from the perspective of the global data. For the calibration, as Bente and Michal already mentioned, it's very nice to get some local data from weather stations, some historical data, and of course, in some setups, you will get just temperatures, and therefore we cannot calibrate, for example, the water cycle. But so it depends on the sensors and the data available from the sensors, what we can compare. But in general, the calculation looks, for example, like this. So I will continue. For a particular place, I search to the past, like from 2019 actually to 1980. You get the last freezing. So this is like 80 days from January 1st in Northern Hemisphere to, so you can see like here the period of freezing is decreasing. And again, here it comes longer from the 21st of December. So again, there is like decreasing the freezing. It's less freezing in fall and in winter. If you combine these two information together, yeah, one thing is that you have the measurements, and then you can put the line of trend here, which you see the red one. So from that you can assume that there is something happening actually in the area of interest, and this is something which maybe is not that spottable for a person living there because the change is very small. But if you look at the next graphs carefully, you will see that in almost all of them there is some trend of changes. Yeah, that's what's just a side note. But from this, I can calculate the length of the frost-free period here, and you can see in our place of interest, it's getting wider and wider. As I mentioned, you usually do want to know the probability of freezing, not the last freezing day in last year or the year before. But if you like take for example 10 years and you calculate where only 1 year after that that particular day it was still freezing, so this is what this map tells you. So you can say like in this area after the 1st of May there is only 10% of freezing, and vice versa goes for the fall period. If you look with like there is still 50% chance of freezing after the date, so you can see that we are now in the middle of the April here, but there is 50% chance to still get some freezing. So this is sometimes the information which the farmer can somehow use and discuss what will, you know, if you plant corn or wheat or whatever, you can manage the date of planting. But if you have like apple trees, etc., you cannot do that. You have to take some other operation to avoid the freezing, like spraying water to the flowers, etc. So it's not suitable for all plants, but for some you can use this. Then we actually calculate something else from the temperature, and it's like temperatures above some thresholds. You can see the thresholds here for something which is called C3 crops. This is I think wheat is in that group. This is some agriculture categorization, and you can see that this we talk about GDU and GODU because we are searching for the optimal. You can see for the optimal thresholds. You can see here as well. So you can see how it looks like in the GDU. Generally, if you convert it to growing days, called also GDD, you can also search for years where the temperature was too high. It's not happening that much in our area, but could be a severe risk in other areas. So you can see temperatures like above the absolute maximum 38 Celsius, for example. So these are risks which happens very rare in our area, but I can imagine in Africa it could be the other problem. And what is also very important, you can see how the growing degree units are changing during a year. Here is it in a week perspective. So if you have a some kind of a model how your corn or whatever how it grows, you will see there that it needs the maximum of growing units like in the week or of 21 to 23, and you can compare if in that particular time you can get enough GDU for your crop. So this is how to work with the data. And honestly, we still have some outputs from the analysis, but the interpretation to which is understandable for the farmer, this is something we are still a bit lacking, to be absolutely honest. But this is something we want to focus on in the future for sure. Okay, next factor. I'm not sure if I'm getting too long, but this is the nitrogen application windows, which says that the temperature should be below 10 degrees Celsius. So you search the last day, when is it above that? And after the temperature goes from 10 degrees to 0, that's the suitable period. For this, for the fertilization, there is another factor which is necessary, but you cannot get it from the historical data, but you have to gather it from weather forecast. It's some raining conditions, so you have to combine these two factors together and then select what is called nitrogen application window to be sure that the nitrogen will transport smoothly into the soil, and it wouldn't be like runoff by some rain, etc. Yeah, and the raining conditions, this is what I meant. You can get from the weather forecast for sure. Accumulated solar radiation, again, it's another form of it's a bit different than temperature, but still you need to understand how much you can get in the area of interest, and if it's enough for your plant. So for that, again, can be very useful to see even the distribution during the year, not just having the year averages as is here. So here is the weekly solar radiation. You can see it in accumulative way. So it's just a different visualization of the same data. Again, these are weak data. And if you know that you have a crop that needs like 50,000 of the units, you probably don't plant it here because you can't reach that much solar radiation. But if you have plant like with 3,000 need, it's pretty safe to do so. But probably you will get some problems with the heat stress units. Maybe, I don't know. Yeah, now we go to factors which are related to water cycle, which is in a naive way mentioned here, like there is some precipitation, it goes to the soil, something runs off, and what goes into the soil, it's kept in the reservoir, something is absorbed, and there is the evaporation, transpiration. And actually, what is the difference in between this and this is the water balance which you can get. So I think if you take a look at these graphs, you can understand. Maybe this is the most important graph. Like, see in which years. Here you can see some. Okay, yeah, this is these are weeks in in this period. So this is some average for 10 years. So you can see like during the spring you get the accumulation, then there is the dry season, and again you get something for accumulation. So this is very important for the operations. But again, if you look at the trend, there is some maybe alarming trend here, because the water balance is decreasing here in this area. I promised to talk about the story of a place, but I spoke about the story of a plant as well, at least a bit. But what is needed to take the story of a plant here seriously is to have some model, like how much water the plant needs in particular weeks of its growth. The same for nitrogen and for other factors, and then you have to compare it with the outputs from the climatic data, and say, okay, this plant is suitable to grow here or it's not suitable. So this is the combination with the plants data, and actually now, okay, how all of that is able to calculate. I mentioned the ERA 5 land data set. There is also something which is called EDA, the data set with the let's say they say that that's the accuracy of the data. So this is you can work with as the same way as we did. You can also connect some commercial data. We have some discussion with the Meteo Blue company, for example. They have maybe even more precise data, but for now we have connected our algorithms to open data. And if you compare that for before we compare it to the sensor data, you can take a look to this information, and this is the uncertainty in the data, which is gathered from the EDA dataset, as I mentioned. So they say that they are pretty sure with the standard deviation, and you can expect like from minus 33.33 to minus 44 to plus 4.44 differences. If you actually compare it to the real measured data, the situation is even a bit worse. It's not that visible from this graph, but from this graph it's much visible. This is demonstration not of the temperatures, but just the difference in between the temperature from the sensor and from the climatic data service, from the global data. And you can see like there is the standard deviation is about 1 degree, and the minimum and maximum could be in this way. So that's not that ideal situation, and we actually now work on let's say first some calibration of the data, of the global data to the local data. That's one branch of our research, and the other branch of our research is actually to propagate the uncertainty from the input data, such as temperature or whatever measured, into the agroclimatic factors. So in the ideal world, we can, let's say that we can tell to the farmer that if you want to plant a corn here in your area and you start at the 1st April, it will be ready to harvest like on the 1st of September. And if you tell him the information from the climatic data service, from the global data only, you will then need to let him know, okay, we say 1st September, but it could be like 5 days before or 5 days after. If we calculate it from sensor data, from local data, then we are probably able to let him know that it will be 1st of September, and the inaccuracy is like just plus minus 1 day. But for situations when the farmer doesn't have the weather station, at least some information will be ready just from the global data. Yeah, so this is a bit discussion about data quality and the story of the technology. This is the last story I would like to talk about. Again, there is a link to the GitHub, as I mentioned, and maybe this one thing I haven't mentioned is that if I open the page again, I mentioned that there is the description of the algorithm, of all the algorithms, and also you can go there to the code page and you can download the algorithm. They are written in Python. You can cooperate with us on development, whatever you want. And I will just briefly mention that this is actually output of the project EUXDAT. If you go to this page, it's not loading because of the streaming. I'll put it into the chat. Unfortunately, you need the credentials to log in, but if you are interested, we are able to provide you ones. And there are some other activities in the project, but what is there is the agro-climatic zones calculation, which is what I talk about. You can reach the calculations in two ways. First, when you want to play with us with the data, there is the Jupyter Notebooks environment you can work with, and the algorithms you can download actually from GitHub. You can run here at the server, and you can get the information for your particular area. Then, if we have the process polished enough, then we are ready to actually prepare some kind of graphical user interface where you can calculate it as a user, and when you calculate it, you can download it in GeoJSON. I had all of these things prepared, but then my browser crashed, so I'm not going through this interactively now because it would take us like 5 minutes more, and I think it's not the case we want to go through right now. But if there is a bit time at the very end, I can give it a try. Yeah, so that's about the technology. And yeah, I have just screens here in a case it wouldn't be able to present interactively. So this is basically end of my presentation, and I hope that the story of a farmer which is searching for a place which is suitable for a particular plant and uses data and up-to-date technology for that is something what was worth to listen to for the few tenths of minutes. So thank you for your attention. Here you can find my email, and I will copy the email into the chat as well. Yeah, that's all from me for now. Thanks.
Thank you so much, Carol. Indeed, and you know that I will ask you to post your email address also in the chat. Yes, I just wanted to. I am asking you a few questions. Well, I've asked you one question already. I will report from the result of the first poll after Michael here, and then we have a second poll just to figure out a little bit about your background. But I think we go, in the interest of time, Mike, I think we go straight to you, and then if I don't see any questions. No, not now. So you can ask questions after Mike as well, or during Mike's talk. Mike, the floor is yours. Introduce yourself first, remember, and start your talk.
Okay, thank you, Bente, for the floor. My name is Mike. I'm working as GIS expert and researcher, partly at the University of West Bohemia, partly at the Baltic Open Solution Center. So my professional focus is on sensors and sensor data and processing of this data. And I would like to introduce in the presentation our, let's say, sensor data management solution that is collecting data for this agro-climatic factors, calculations, and assessments. I will now switch. So I would like to present an interoperability solution for sensor data called SensLog. So it's a product of many project work and a lot of development. I would like to be short because we are a little bit running out of time. So the motivation for this comparison is that the sensor data are producing a lot of important information, and they are connecting real world with our modeled and simulated situation. So we are trying to compare what is the real world status to our modeled and our lower granularity data comparison. So SensLog as solution is web-based and cloud-based data management application that is storing, managing, processing, and publishing sensor data. It is suitable for in-situ sensors as well as sensors deployed on some mobile carrier or some data collected by smart devices. So let's speak about only geographic information. SensLog works with REST API, so it's possible to communicate with the solution with a complete set of web services. So it's possible to connect it with other applications. We have two versions of SensLog. We have older version 1 that is mainly web-oriented and real, let's say, one combined solution for collecting of data. It has several modules for VGI or for farm telemetry. It has a proprietary interface based on REST API and SensLog JSON data encoding, but it has a standardized interface based on OGC sensor observation cells. For version 2, we have improved the scalability of the solution. So now it's designed as a microservices system. It's mainly cloud-oriented and is a robust solution for, say, large campaigns of data collection. It again has REST API with JSON encoding of data, but we are now working on standardized interface based on OGC sensor ThingsAPI, and we are thinking about other interfaces to be implemented. So on this slide, you can see the overview structure of SensLog. So on the left side, you see feeder and connector modules that are responsible for collecting of data to processing part, that is, as it calls, process the input data and stores to the main data storage. On the right side, there is analytics component that is responsible for some statistical calculations or for some threshold observing or for some long-term analysis. The main communication part for publishing data is provider module, that is in many instances responsible for communication and publishing of data. If you look on the diagram for, let's say, data flow, on the left side you can see many data sources for SensLog, starting from classic static node with sensors and with many inputs. You can produce data by smartphone or by mobile applications, or we can, let's say, integrate data from different data providers. For that purpose, we have designed and developed SensLog Connector module that is responsible for this connection between different APIs and different interfaces. On the right side, you can see, let's say, target users or targets for our data publishing. It can be any other component in the data chain from third party or from other analytics component. It can be, again, smartphone with some visualization or with some let's say analytical results, or again it can be some data consumer that is just loading data from all data storage and using in many purposes on their side. To improve the interoperability of SensLog, so we have designed this SensLog Connector. It's a real standalone connector that translated interface from one type to different type, and to download or let's say receive data from different data provider services in a way that we are not, let's say, responsible for the interface this data providers is implemented. So that's the component SensLog Connector. It allows both, let's say, modes, not only pushing data but pulling as well, or it's working as a proxy, so you are able to request and download data in many different APIs. So it's just a component for translating data. At this moment, we have implemented connectors for Agro-climatic database or Agro-climatic data providers. We have a connection with IMI company Azure data storage. We have working for some connector for project Alpha Cloud, so for their solution. And we are almost in beta testing of ThingsAPI connector. So I hope during the hackathon it will be finally tested. The structure of the connector is on one hand very simple, on the other hand it's okay, structured for multi-purpose solutions. So we have spent a lot of time with this design to be able to really build up a connector for different purposes and for different interfaces. So it's variable solution and ready to use after short time of updating of end interfaces. That's a very short overview of mapping between ThingsAPI and our data model. We can say that it was many years ago good point to design our data model based on observation and measurements standard. So at this moment we are able to map very shortly between our data models. Few words about the hardware part we are cooperating with. We are mainly using Agro solution that is developed by a company Respect. It is autonomous telemetry station that is collecting data from sensors, from physical sensors connected to this telemetry station, and it's sending data over IoT networks or GSM network to the database. So we have many successful use cases in cooperation between Agronode and SensLog as data storage. So it's one of the solutions we are using. So we are cooperating with let's precisely on many sensor campaigns. For example, collecting and measuring data about groundwater in Czech protected area. We have cooperated with farm telemetry development, so for observing tractors on farms, or we have mobile application for collecting of DGI in directly in terrain, and so I can SensLog as well. Back to our challenge for this assessment of sensor data and ERA dataset. We have selected two pilot localities where we have deployed meteor stations mainly between years 2016 and 2018. We have two different meteor stations records, and to be able to compare this data, we have selected 5 phenomena we were observing on both localities. So it's mainly air temperature, humidity, and pressure, and precipitation and wind characteristics. So with this 2 hours frequency, we are able to compare data of this locality. So that's all from my side. I will put my email in the chat, and if you will have questions, it will be my pleasure to respond.
Thank you so much, Mike. Indeed, very interesting challenge that you are presenting here, with lots of different aspects that you can be contributing to, right? You can have knowledge about agriculture, you can have knowledge about climate, you can have knowledge about data management, and also more technical on sensors, right? All of these will be useful.
Yes, exactly.
Yeah. I see that we are a little bit longer than at first anticipated. I promised Rodrigo to be invited in here. So since I don't see any other questions, I will quickly see if Rodrigo, if he's still with us. You are hereby invited, Rodrigo. Hopefully you hear your name if you didn't see that you got the invitation. So now you know. You have been, as you said, you have been working on this over several years. Over several INSPIRE hackathons, and I just want to motivate also the audience here, because this is one of the INSPIRE hackathons. This is dedicated to COVID-19, addressing issues related to that. But you see that by engaging, even in a small way, right? You will have the ability or opportunity to contribute into further hackathons where I'm sure you will bring up this topic again. Am I right?
Mm-hmm.
Yeah.
Yeah.
And one more observation. As far as I understood, you are using open source all the way.
Mm-hmm.
Yes. And you are using, well, the Copernicus data, so satellite data from Sentinels, they are open. You mentioned also, how about those sensors? Are there only open data there, or have you also non-open data that you analyze?
Let's say data from these meteor stations are collecting during the time of 2 different projects where our company was involved. So it's strictly not open data, but we are using it for this testing purposes.
Okay, so this is a pilot. Yeah.
Piloting data.
Would you say that? So I assume that some farmers have metro stations on their farm. If they're big farms, I'm pretty sure that they have. On smaller farms, maybe not. But yeah, that's another thing. This method here is best suited for big farms, or is it, you know, where you have big fields, or how small can the farm be before they can actually benefit from this?
Maybe Carl, if you would like to comment.
If you have farm big enough, you probably don't have it covered, like all the fields of the farm. You probably don't have covered with sensors. So then you can use your sensors together with the global data to like spread the information to other fields as well. And if you're a farmer with no weather station, then you can benefit from at least some, not that precise, but at least some information which is better than nothing.
Yeah, right. Yeah. So it depends on you will benefit, and particularly from the trends, I assume that you are.
Yeah. The use case would be different for a small farmer than for a bigger farm, but we feel that there can be use cases for both of them. That it's phrased in this direction. The other thing is that you can easily connect these algorithms to another data, and we know that, for example, the Meteo Blue company I mentioned, it's our partner in the EUSTAT project, and this is they have the very similar data, but they sell it on commercial basis. So if like if you see it's worth to work on, you check it on open data, then you can maybe as a farmer decide, okay, that's something, but I would like to see how it works with commercial data, which are more precise, and that could be some, let's say, scalability. You can get something for free, something for let's say limited amount of money, because the data, the global data, even commercial, wouldn't be that expensive as to run and operate your own meteorological station, I guess.
Yeah. So the economic gain here, if you have a huge farm, there is potentially a lot of money to be saved and a lot of money to be made if you optimize your operations according to the climatic conditions, right?
Yeah. I have to say that we are better with playing with the data than with selling the results. So we still consider us as scientists, and then maybe there is some commercial output of that as well, but this is, let's say, in a second row for us.
Yeah, you are. Yeah, this is in an early stage that you're experimenting and trying to find good methods to give precise information, and eventually, as you said, communicating all this graphs and so on. I'm pretty sure the farmers, having a small farm myself, is like, even with my background, how can you use this? And the people I know around me, they go like, oh, let them use their computers.
I agree. It's to turn the data, even the graphs, into the information you can understand at the first glance. This is very important task in the process of getting the information to the end user.
Yeah, so that's the next step. So if you join this in this challenge now, you will be like a pioneer in this field. And I also want to, what is obvious to me is that it's also preparing for climate adaptations in agriculture. I mean, we are talking a lot about that. That's not the topic. Agro-climatic factors is not really the climate you are concerned with, but in the fact that you are looking at the trends of the climate, and that you can then couple that with optimal choice of crop, say, it's also a way of preparing for adapting to climate change. So say if you used to have a very wetlands, and then suddenly you have more dry area, or the other way around, you can adapt.
Yeah, I agree. This is before we started, or at the phase we started, I was really curious to actually see if I can find something in the data, and it seems that there is something. So this is very important to make your decisions based on data or relevant objective information, not just feelings like, okay, it was yesterday, it was also hot, so probably we are entering dry periods or whatever.
And all these old sayings, I mean, there's a lot of knowledge in the cultures, right? With, seeing signs in the nature. Okay, now it's probably going to be the first night of below freezing point here in the northern hemisphere is like, oh yeah, we smell it in the air, we see something. That kind of observations is hopefully getting more precise and more data determined in the future. That's what you are partly also working on here, I think.
At least we hope so.
Yes, you hope so. The SensLog. So what you are, Mike, just to highlight that as well. So the SensLog is a way of collecting. So when you're talking about connectors, you are actually referring to connecting to the data itself. So you connect the stream of data to a repository somewhere that will then be used for where you can analyze the data later on, right?
Yes, exactly. We are at this moment working or converting SensLog not only to, let's say, data storage or data collector from one sensor or one series of sensor, but we are working on or moving to, say, data integration. So we are trying to collect sensors from different, not only sensors, but from any data providers. So we try to harvest data on one place.
Yes, exactly. So this is a challenge, and I wanted to highlight this as well, this interoperability issue with, all these different types of sensors from different countries and what have you. And this is something we putting on my Plan for All hat here, that we are really interested in making the data interoperable using standards. And that's why we also called INSPIRE hackathon. It's about making the data accessible through standardization and other means, right?
Yeah, right. You're right.
So this you can work on if you join this challenge here. And I'm sure it's also an investment for the future. If you have a small contribution now, or you want to dive completely full in, there will be a future going on after this hackathon as well. The deadline, the finals of this hackathon is in the middle of, or was it the 19th of November? Oh, Hannah will kill me.
I think on 12th we should provide the final reports, but I can double check that.
Yeah, we are in the midterm reporting period now, and then there are this finals on the second half of November when the finals are. But that means that you should complete your work before that, so that you are able to present it in the final event. So there's still time. That's my point. It's still time to join you.
Yeah, definitely.
Yeah. Okay. I don't see any questions, and maybe Rodrigo gave up on us. I haven't seen any attempt to get in here, and no new hand. So do you have anything final words, or should we call it a day? We are 15 minutes after the 1 hour now. So
that's my fault. Sorry for that.
No. It's been a very interesting and informative webinar, I think.
Okay, thanks. We hope for. So yeah, final words. I think I already covered that at the end of my presentation. If anybody would like to join, yeah, go ahead. We will invite you.
Very, very good. So I almost forgot, sorry for that. We did a poll, 2 polls. So if the first question was if the audience were familiar with agro-climatic factors, and 33% of the audience said yes, 46 would like to learn about it, and 20% were not sure. So it's a good mix of distribution. And the next question I asked about, since satellite data is one of the data involved in this processing, I asked about if their experience on processing satellite data. And we have 50% who have experience with that. They have processed data for agricultural applications, which is relevant. And 33% have processed satellite data for other thematic areas, also relevant. And also relevant is that no, but you want to. So there's 11% that want to learn about processing, learn to process satellite data, and 5% are not sure. So that was a very good. Thank you so much for participating in the polls. It's very useful for us to learn, not only for the team here, but also for us who organize all these webinars and these hackathons. So thank you so much for that. With that, I will wish you the best of luck, Mike and Carol, and I also encourage you to join this team if you're interested in any of these aspects that you learn about today. Okay, bye-bye for now. We have a new webinar tomorrow at 10 o'clock, so follow Plan for All. Bye-bye.
Bye. Thank you, Bente. Thank you, Bente, for organizing.